Good day, everyone. Today we're going to dive into a fundamental concepts of trigonometry. Our focus will be on three key learning objectives. Number one, using correct mathematical notation and terminology. Number two, defining and drawing the unit circle while identifying the coordinates of special angles. And number three, identifying the six trigonometric functions and their value limits based on the unit circle. By the end of this discussion, you should have a strong grasp of these concepts, which are essential of mastering trigonometry. So let's begin. So our objective number one is using correct mathematical notation and terminology. Mathematical notation is the universal language of mathematics. In trigonometry, precision in notation ensures clarity in problem solving and communication. Here are some key notations and terminologies. First is angle representation. We use degrees and radians to measure angle. For example, 90 degrees is equal to pi over 2 radians. Second is trigonometric functions. This include sine, cosine, tangent, cosecant, secant, and cotangent. We also have coordinate notation. Ordered pairs of x and y represent points in the unit circle. We also have Greek letters such as Greek symbols like theta and alpha are commonly denote angles. For example, the sine function of an angle theta is written as sine theta. Using improper notation such as writing in sine theta equals 0.5 without parentheses can lead to confusion. Now let's move on to the unit circle. So our objective number two is defining and drawing the unit circle and identifying special angle coordinates. Unit circle is a fundamental concept in trigonometry. It is a circle with a radius of 1 unit centered at the origin of 0 and 0 in the coordinate plane. So the equation of the unit circle is x squared plus y squared is equal to 1. To construct a unit circle, let us take 3 steps. Step number 1, draw a Cartesian plane. Step number 2, plot a circle centered at the origin with a radius of 1. Then step number 3, label key points where the circle intersects the axis. 1, 0 at 0 degree or 0 radius. 0, 1 at 90 degrees or pi over 2 radians. Negative 1 and 0 at 180 degrees or pi radians. And 0 and negative 1 at 270 degrees or 3 pi over 2 radians. While 1 and 0 again at 360 degrees or 2 pi radians. So for the special angles, the most commonly used points correspond to 30, 45, and 60 degrees in the first quadrant. Now, are you one of those students who hate memorizing trigonometric formulas? So in this video, we are going to talk about strategies on how to remember 64 math formulas by just using your magic fingers. Begin by labeling our fingers. First, we draw a right angle representing the first quadrant of Cartesian plane, then 0 degrees start at this position, and 90 degrees angle will be in this position. The middle is our 45 degrees angle, 30 degrees is located here, and lastly, 60 degrees at this position. With this labeling our magic fingers, we are now ready to find the exact values of trigonometric functions. First, just for this particular technique, here is the formula. The sine of the angle is equal to the square root of number of fingers below over 2. For example, if I want to find the sine of 45 degrees back to the 45 degrees finger, there are two fingers below the 45 degrees finger. Using the formula, sine 45 is equal to square root of 2 over 2. Next, if I want to find sine 30, I count the number of fingers below this highlighted finger and there's only one. Therefore, sine 30 is equal to square root of 1 over 2, or just simply 1 half. If I want to find sine 60, I count the number of fingers below the highlighted finger and we have 3. So the answer is sine 60 is equal to square root of 3 over 2. For sine 90, we count the number of fingers below the highlighted finger, which is 4. So the answer is sine 90 is equal to square root of 4 over 2. So square root of 4 is 2 is equal to 2 over 2, or just simply 1. So lastly, for sine 0, there is no finger below the highlighted finger. The answer is sine 0 equals 0. Now let's talk about cosine of special angles. Here is the formula. The cosine of the angle is equal to square root of number of fingers above over 2. For example, so cosine 45 count the number of fingers above, which is 2. So cosine 45 is equal to square root of 2 over 2. For cosine 60, there is one finger above, so the answer is cosine 60 is equal to square root of 1 over 2, or simply 1 half. For cosine 30, there is 3 fingers above, so cosine 30 is equal to square root of 3 over 2. For cosine 0, there are 4 fingers above, so cosine 0 is equal to square root of 4 over 2, or just simply 1. While cosine 90, there is no fingers above, so the answer is cosine 90 is equal to 0. So in unit circle in the first quadrant, now that we have these trigonometric values, we can now construct our unit circle. Position your fingers in the first quadrant of the unit circle as shown in the diagram and contribute the angles. To find the coordinates of a point, the x-coordinate is the cosine and the y-coordinate is the sine. For example, the coordinate of 0 degree is cos 0 and sine 0 is equal to 1 in 0. So the coordinate of 30 degrees is cosine 30 and sine 30 is equal to square root of 3 over 2 and 1 half. The coordinates of 45 degrees is cosine 45 and sine 45 is equal to square root of 2 and square root of 2. So they're just the same. While the coordinates of 60 degrees is equal to cos 60 degrees and sine 60 degrees is equal to 1 half and square root of 3 over 2. And the coordinate of 90 degrees is cos 90 degrees and sine 90 degrees is equal to 0 and 1. So by following this pattern, we complete the first quadrant of our unit circle. In the second quadrant, to create the quadrant, we reflect the first quadrant across the y-axis, then we assign the angles. So 90 degrees plus 30 degrees is equal to 120. So 90 degrees plus 45 degrees is equal to 135. So 90 degrees plus 60 degrees is equal to 150. And 90 degrees plus 90 degrees is equal to 180. Since the second quadrant is a reflection of the first quadrant, the values remain, but the x-coordinate becomes negative. For the third quadrant is a reflection of the second quadrant. Across the x-axis, the angles are 180 degrees plus 30 degrees is equal to 210. 180 degrees plus 45 is 225 degrees. 180 plus 60 is equal to 240 degrees. 180 plus 90 is equal to 270 degrees. In this quadrant, both x and y coordinates are negative. So in the fourth quadrant, to create the fourth quadrant, we reflect the first quadrant across the x-axis. The angles are 270 plus 30 is equal to 300 degrees. 270 plus 45 is equal to 315 degrees. 270 plus 60 is equal to 330 degrees. And 270 plus 90 is equal to 360 degrees. So the values remain the same, but the y coordinates are negative. So radians measurement. In the unit circle, one full revolution is equal to 2 pi. Half revolution is equal to pi. 1/4 revolution is equal to pi over 2. And 3/4 revolution is equal to 3 pi over 2. Now let's assign radian measures. 0 degrees is equal to 0. 30 degrees is equal to pi over 6. 45 degrees is equal to pi over 4. 60 degrees is equal to pi over 3. 90 degrees is equal to pi over 2. Following this pattern, we can calculate the radian values of the entire unit circle. So, for application, let's find some trigonometric values using radians. So, cosine or 4 pi over 3. So, let's locate the 4 pi over 3 in the third quadrant. The x-coordinate is negative 1/2. So, cosine 4 pi over 3 is equal to negative 1/2. Sine 7 pi over 4. So, let's locate 7 pi over 4 in the fourth quadrant. The y-coordinate is negative square root of 2. So, sine 7 pi over 4 is equal to negative square root of 2 over 2. Now that we understand the unit circle, let's explore the 6 trigonometric functions. So, our objective number 3 is identifying the 6 trigonometric functions and their value limits. So, trigonometry is built on 6 fundamental functions. First is sine. Represents the y-coordinate on the unit circle. It has a formula of sine theta is equal to opposite over hypotenuse. Second is cosine. Represents the x-coordinate on the unit circle. Cos theta is equal to adjacent over hypotenuse. Third one is tangent. Tangent is the ratio of sine to cosine. So it has a formula of tangent theta is equal to sine theta over cos theta. The fourth one is cosecant. Cosecant is reciprocal of sine. So it has a formula of cosecant theta is equal to 1 over sine theta. The fifth one is secant. Secant is a reciprocal of cosine. So it has a formula of secant theta is equal to 1 over cosine theta. Next one or the last one is cotangent. Cotangent is the reciprocal of tangent. So it has a formula of cotangent theta is equal to 1 over tangent theta. So the domain and range of trigonometric functions. In sine and cosine, it has a values between negative 1 and 1. Tangent theta and cotangent theta can be any real numbers but are undefined where cosine or sine is 0. while cosecant and secant have absolute values of greater than or equal to 1. It's never between -1 and 1. So example questions. Evaluate tangent of 240 degrees. So 240 degrees is in the third quadrant. So the reference angle is 60. So tangent 60 is equal to square root of 3. And since tangent is positive in the third quadrant, tangent 240 is equal to square root of 3. In summary, today we covered the importance of correct mathematical notation and terminology, the unit circle's definition, its equation in the coordinates of special angles, and the last one is the 6 trigonometric functions and the reciprocal identities and their domain and range. Thank you very much, and I hope to see you again in our next video. Thanks for subscribing to our channel. Bye for now.